In today's lesson, we are going to be looking at intersection of lines. So we're going to be taking what we've looked at so far, and we're going to now apply it to when we have two lines graphed at the same time, or two equations in the same situation. So we're going to start off by looking at a problem. And the problem in this case is that there are two amusement parks in a city. Mathemagical World, which charges a $20 admission fee, plus an additional $2 for each ride. And Radical Island, which charges $3 for each ride, but does not charge an admission fee. So the question is the following statement sometimes, never, or always true? And that statement is that Radical Island is the cheapest choice. Now, you might be able to take a look at the scenario and kind of come up with an idea of what your answer is already, but we want to come up with a convincing argument to back up our answer. And when coming up with your argument, we are going to look at graphs, equations, and tables of values to help us show our reasoning. And to work with a graph, we can go to Desmos. So we can go to desmos.com and create the graph for us. So when we do that, we end up with the following graph. So we can see, let me see, it was Radical Island in blue and Mathemagical World in purple. So again, the question was, Radical Island is always going to be cheaper. Now for Radical Island, again, when we were graphing this, we had to come up with an equation. From the statement, from the graph here, we can see that Radical Island has a constant of 0. So we know the equation will be y equals something x plus 0. To figure out the multiplier, we can look at two nice points. We've kind of indicated here and do a rise over run. So our rise in this case goes up 30. Our run is 10. So in this case, m equals rise over run, or 30 over 10, or 3. So our equation is y equals 3x plus 0. And again, you may have gotten that rate from the word scenario as well. For Mathemagical World, again, trying to come up with an equation, it'll be y equals something x plus or minus something else. Again, we can see the constant starts at 20, or the y-intercept is 20. And again, we can use nice points to figure out our rise over run. So we go up 20, we go run 10. In this case, m equals rise over run, or 20 over 10, which equals 2. So again, this is similar to the equation, which tells us that our multiplier is 2. And again, you may have gotten that rate from the equation. So looking at this, looking at our graph here, we want to answer that question, that Radical Island is always cheaper. So let me just move these off to the side a little bit, because again, we don't really need these too much because we've already graphed them. But let's take a look. Our blue line, when is it cheaper? And in this case, cheaper means it's the lower line. So if we look at our blue line, or Radical Island, we could say Radical Island is cheaper, or we can say it's the lower line up to 20 rides. We could then say, well, after 20 rides, Mathemagical World is cheaper. So Mathemagical World is cheaper after 20 rides. And then you might be thinking, well, what about this point here? Right? We have this point circled, or we've indicated that this point is important, or we've at least put the coordinates in. So at this point, neither line is higher. So you could say at 20 rides, they cost the same. So in this case, we have three different scenarios. We have Radical Island being cheaper up to 20 rides. We have Math Magical World being cheaper after 20 rides. And at 20 rides itself, they cost the same amount. So that's how we can answer this question. So based off of our graph, we could say that Radical Island is sometimes cheaper. And we can see that by looking at the graph for which one is lower. We're going to try to do the same thing with a table. So with our table, again, if we look at Radical Island, the equation we got was y equals, I believe it was 3x. And for Math Magical World, our equation was y equals 2x plus 20. So we are going to use these two equations to fill out the table. So again, you could think of it as plugging the values in, or the number of visits into the equation. So you could say y equals 3 times 0, in this case equals 0 for our cost. Next one, y equals 3 times 5, which equals 15. So the cost is 15. If you did it for 10, you'd get 30. Then 45, 60, 75, and 90. For Math Magical World, you're going to do the same thing. You're going to plug in the value. So y equals 2 times 0 plus 20. 2 times 0 is 0 plus 20 is 20. So therefore, the initial cost, or when there are 0 visits, or the constant, is 20. So again, we've talked about that before, so we should know that the constant, or the 20, goes in for the 0 spot. For the next one, y equals 2 times 5 plus 20, or 10 plus 20, which is 30. For 10, if we plugged it in, we'd be 40, or you could think of every 5 rides as adding $10. So 50, 60, 70, and 80. So using that, move this to the other side. Looking at these two tables, we can see when one is cheaper than the other. So in this case, we should again recognize that they share the same values at a specific point. So on our table, they cost the same at 20 visits, or yeah, I guess visits instead of rides. We could say then, up to 20 rides, we can see that Radical Island is cheaper. The cost is cheaper up to 20 rides. So Radical Island is cheaper up to 20 rides or visits. And then for Math Magical World, we can see that after 20 rides or 20 visits, Math Magical World is cheaper. So again, by creating the table, or a table of values for our two parks, we can see that one is cheaper than the other up to a certain point. At a certain point, they cost the same, and then after that point, one is cheaper than the other. So again, the same thing that we saw in the graph. Looking at the specific equations, so again, going back to radical island, we had y equals 3x. And looking at mathematical world, we had y equals 2x plus 20. Now, when we look at just the equations, we may not be able to get the specifics, but we might be able to at least pick out some information. Looking at mathematical world, we can see that it has a constant. Looking at radical island, we would say it does not have a constant. So because radical island does not have a constant, right off the bat, it's going to be cheaper. So because it doesn't have a constant, it will have to start off cheaper compared to mathematical world. So mathematical world will start off more expensive. Then looking at the second part of the equation, the multiplier, radical island has a larger multiplier, a multiplier of 3, where mathematical world has a smaller multiplier. So what this means, again, we've talked about the multiplier telling us what we're increasing by every time, or the rate of change. And we've also mentioned that the larger the multiplier, the steeper or the faster it's growing. So because radical island has a larger multiplier, that means it's going to be increasing at a faster rate compared to mathematical world. Because it's increasing at a faster rate, or has a larger multiplier, it will eventually pass or eventually become more expensive. Because it has a larger multiplier, it will become more expensive. Again, it's just a matter of when it becomes more expensive. Fortunately, just by looking at the equations, you can't really tell that. You would have to do one of two things. Again, graphing it, creating the table, or what we do next. So because mathematical world has the smaller multiplier, even though it starts off more expensive, it will eventually become less expensive compared to radical island. So by looking at the two equations, we can at least determine which one's going to start off more expensive and which one will end up or become more expensive based on looking at the multiplier and the constant. The next solution, looking at algebra. So this is kind of a little bit of an extension. You will cover more of this in grade 10, but just to give you an idea of what we're starting with, again, we have our two parks, radical island being y equals 3x, and mathematical world being y equals 2x plus 20. So we've done something like this before in something like this before in our equations unit, but what we're doing is we know that these two lines will eventually cross. So we know that these two lines will cross eventually, or in other words, when they cross, means the same thing as saying they have the same values of x and y. So if they have the same values of x and y, that means their y values will be equal and their x values will be equal. So when that's the case, and again, we've dealt with something like this before in the solving equations unit, if the y values are equal, well then I can say that 3x will have to equal, use a different color, 3x is going to have to equal 2x plus 20. If at some point when they cross, those values are the same, we can set them equal to each other. The equations are going to equal each other, they're going to equal the same value. This is a multi-step equation now. And I can go through and solve this multi-step equation. Right? I can collect my x terms or get rid of them on one side. So we're going to minus 2x on one side, minus 2x on the other side. One side will cancel out. I'm left with 1x equals 20. I could divide both sides by 1, or understand that 1x is just the same thing as saying x, which equals 20. So that means that x equals 20 when these two equations are the same. Or in other words, you say therefore, the number of visits where they are the same is 20. And if we want to go back and figure out what the cost is at that point, well, I can have two equations to figure that out. Y equals 3x, or y equals 3 times 20, which equals 60. I could also do the other equation, y equals 2x plus 20, or y equals 2 times 20 plus 20, or again, y equals 60. So it doesn't matter which equation I use here. I know, or I've determined already, that the values are going to be the same. So then therefore, the cost at 20 visits is $60 for both parks. So again, that's how you would do it algebraically. Now again, this is something you're going to do more of in grade 10, but just to get, we have covered something like this before, and we have solved multi-step equations, so we have used the tools to solve this. It's understanding how we start off or how we put it together, which may be a little bit difficult, but again, we have the three other methods in terms of determining when these parks cost the same or when one is cheaper than the other. So in conclusion, the original problem was, is the following statement sometimes, never, or always true? And the statement was, Radical Island is the cheapest choice. Now, when looking at the different ways to investigate this, looking at the different representations, we can see that there are three different cases. One being at exactly 20 visits to the park, both places cost $60. So that means either option is the same price. It doesn't matter which one you choose, the cost is going to be the same. We also found that under 20 visits, Radical Island is the cheapest choice. And then over 20 visits, Mathemagical World is the cheapest choice. So again, we've found these three different scenarios, so that means that it is sometimes true. So we'll circle it, highlight it, that's our answer. It's sometimes true. So in summary of what we did, when working with two different lines, the solution of the lines is considered to be where the point where the lines meet. So this means that at a certain x value, the y values will be the same. If we're looking at a context problem or a word problem, like the amusement park one we just looked at, the conclusions that we're going to have to draw come in three parts, or there's three parts to our conclusion. One part where the values for both scenarios are the same, and we call this the point of intersection. A part where the line or the values of line 1 are lower and line 2 is higher, and then a third part where it's the opposite. The values of line 1 are higher and line 2 are lower. So again, it doesn't really matter which part comes first or which line is higher first or lower first. Again, in the context, you would be able to understand what that is. So if we have to write a conclusion to a contextual problem, we have to reference all three parts. So if you're asked a question about when is one more expensive, you want to refer to all three parts, when they're the same, when it's more expensive, and when it's cheaper. So keep that in mind when trying to answer some of these questions. So in example 1, so we're going to go through this idea. Rosie is touring a city. She has found a company that rents bicycles and rollerblades. The company charges an initial fee for the equipment rental and then an additional cost per hour of rental. The linear relationship between cost and rental time for both the bicycle and rollerblades is shown. Determine the conditions under which each option is the most cost effective. And by cost effective, we mean cheaper. So if we look at the rollerblades, the dashed line or the blue line, we can see that it is cheaper, or it is lower, up to 4 hours. So rollerblades, we would say cheaper up to 4 hours, because it's the lower line. We can see the red line then being lower after 4 hours. So that means the bicycle is cheaper after 4 hours. We can also see a point, a point right in the middle where that crossover happens, where both lines are at the same point or have the same value. So we could say at the point of intersection, both options cost the same at 4 hours. And we could say in brackets the cost is $15, just for reference. So again, we have our three scenarios. Rollerblades are cheaper up to 4 hours. Bicycles are cheaper after 4 hours. And the point of intersection, which means that both options cost the same at 4 hours, which is $15. So again, we've determined which option is most cost effective, or under which conditions each option is most cost effective, which again, referring to those 3 points or 3 scenarios. Example 2, below is a graph representing the cost per round for the 2 different golf courses. The public golf course runs a junior league with a registration fee of $200 and a cost of $25 per round played. To stay competitive, the private golf club in the same town offers a junior league with a registration fee of $250, but only $20 per round played. So first, we want to determine an equation for each golf course. Now we do have the graph that we could look at, right? We can go down, we can find our 2 constants. We could then also find some nice points and do our rise over run. To find it out. So in this case, for the public one, we'd be going over 4 up 100. Again, using the scale to help us. For the private one, we'd be going over 2 and we'd be going up it looks like 40. Again, when we're given the word scenario, we should remember that we can also get the equation right from the word scenario. If we look at the first one, a public golf course runs a junior league with a registration fee of $200. That registration fee is a one-time fee. You only pay it once. And then you have a cost per round. So right there, that tells us the equation. Y equals $25 for the multiplier, or so 25x, plus 200 for our constant. For the private golf club, we see the same thing. A registration fee of $250, or that one-time payment, and then $20 per round. There's my multiplier. So y equals 20x plus 250. Now we could use those equations and kind of come up with general statements of when is cheap, one better, more expensive than the other. We also have our graph that we can look at. But right now our question is asking us to circle the point of intersection on the graph. Again, the point of intersection is where the lines meet. We can see that there. We can put a dot there. And then we can get the coordinates of this point. So again, remember, coordinates come in an x and a y. If you remember back to the battleship activity that we did, in this case, the x value is 10, and the y value is 450. So that's important because that gives us the criteria, or that gives us kind of that crossover point. So the next question is, when is it better to choose a public golf course and when is it better to choose the private course? Well, the public course is cheaper up to 10 rounds. Because we can see up to 10, it is the lower line, or up to 10 on the x-axis, it is the lower line. The private golf course then is cheaper after 10 rounds, or more than 10 rounds. And then finally we can say at 10 rounds they cost the same. So again, referencing those three scenarios: before the point of intersection, at the point of intersection, and after. So which one's cheaper? Up to public course, after the private course, and at the point of intersection, they cost the same. So again, the main thing from this lesson isn't how to figure out the equations and how to figure out the multipliers. It's understanding that when we're graphing two lines, the point of intersection means that the values of x and y is the same for both equations. And then looking before the point of intersection, one will be lower or less steep, and after, one will be higher or more steep. And in terms of our context questions or word problems, we should refer to those three scenarios when answering any question about the point of intersection.